We'll be talking about like one of the biggest challenge which most of the organization or the projects or the teams face like while working on a cloud, like which is cloud cost management. So before we actually go into the talk, like how many people are like already using like any of the cloud? Like maybe can raise your hand. Okay, good number. So I think you can easily correlate like how or what strategy we recommend to manage this one of the biggest challenge, which is cost management in the cloud. Okay. So before we go further and talk about the strategy, I think let's understand why cloud usage is or infrastructure usage is increasing so much, right? So where scalability is one of the thing. Like you can easily get the infrastructure, you can easily scale it on demand whenever you need it, right? And from a business perspective, like everyone wants to go live to the market as quick as possible, and some of them like wants to go global as well, where you can easily provision your infrastructure like in whatever region you want as per the data policy which applies onto you. Another is like where AI is like another hot topic nowadays, and to do any experiment around it, like you need like vast amount of a storage, optimized GPU, CPU servers, which are like easily available in the cloud. And another is like in cloud, most of the services are like already managed, so it automatically reduce the operational overhead. But with all these features, right, it has its own challenges as well, like whenever you go and try to adopt on any of the cloud, right? And one of the biggest challenges, cost. So now let's look at the strategy, what we recommend. 3693, like understand three type of services, avoid doing 6 common mistakes, apply 9 optimization strategy, and then look at like follow the 3 pillar of governance. So we'll talk about in more detail around this strategy in the upcoming slides.
Yep. Let's start with the understanding the three type of services, right? So, yeah, self-hosted, managed, and serverless. This we all know, we have used in, right? So, but where to apply what? So, since this is a cost optimization talk, right? So, from a cost optimization perspective, we recommend managed services, right? Because it offers cloud portability and also cost effectiveness, right? But there are different sliders in this slide. So it all comes with, it depends, right? So I cannot say managed services is the way to go. There are different use cases. It is dependent on your application needs, your usage criteria, and in-house capabilities, and of course your budget. Correct? So good example is database, isn't it? So when you provision a database, you often go for a managed service. So no one would want to manage a database in a VM or go with a serverless. Why not serverless? Because it is a pay-per-use model. So it gets expensive over a period of time. So you can start for experimentation, but it gets expensive, right? So that's why like we have listed the use cases for each type of services. Like for quicker turnaround and experimentation, we can of course go with serverless, and things like observability cost, CloudWatch, right? So when you have to debug in production quickly, you have to enable VPC flow logs and check, you can do that. And self-hosted services. So sometimes you go for marketplace services, right? Like Kong. The Kong is not a managed service in the cloud. It becomes expensive over a period of time. If you have a in-house capable cloud team, and you have taken care of day-to operations, backups, and availability and DR, then of course you can go with self-hosted services, which is very cheap. So the one thing which is not visible in your budget is the operations cost, right? So that you have to that also has to be considered in your budget. So, but a good service, but a good clouds is a good software catalog is one which has sensible defaults. You have your infrastructure platform and the documentation defined properly, whatever service you use, right? And then let's go to the 6 common pitfalls. So the first one is the over provisioning and unused capacity. So for people who are coming from on-prem, like me, we have a tendency to over provision, right? So when we are doing lifting and shifting, so we tend to provide the same capacity that we had in on-prem. So in on-prem, there is a lot of red tape. So we have faced this red tape, right? So it is difficult to get compute, memory, and disk. So what we do static provisioning. We provision for the peak workloads because it is difficult to get those resources during the peak time. So we do the static provisioning. Unlike in the cloud, it is a dynamic. We have to leverage the dynamic nature of the cloud, right? So this is one common pitfall that I have seen when we do a lift and shift from on-prem to cloud. And the other thing is failing to recognize indirect costs. The good example is network transfer. So when you are on-prem, so we don't consider the network cost because it is negligible, right? So, but the underlying complexity of cloud hides the network cost, right? So which later creates a dent in the budget. Like your NAT gateway cost, your transit gateway cost, inter VPC cost, inter AZ cost, all this cost, actually we might not have considered in the budget, but when you see the bill, you see a long, huge number in your bill rate. And there is something that I learned last year, which is the extended support cost. How many of you know that there is extended support cost in AWS, right? So you might have been surprised to see that huge bill after the month ended, right? So for those who don't know what extended support cost means, if you don't upgrade your EKS cluster on time, you have to pay for it, and the difference is huge. So the basic support is $0.1 per hour. I think it is $0.1 per hour. Whereas extended if you don't upgrade, it is $0.6 per hour. So it is 6x times the cost, right? So we should not forget to upgrade the EKS cluster or RDS cluster, or you will end up having this problem. And long running experiments. Any data engineers in the group? No, right? So those EMR clusters which were created by data engineers for a small experiment was not terminated at all. And in the month, you see a huge budget, right? So every data engineer creates EMR clusters for a short experiment for 1 hour or 2 hours, but that is not terminated at all. There is a feature called termination on shutdown of your jobs, right? If that small flag is enabled, you could have saved in huge amount. And another common pitfall that we see is we don't consider experimentation when we budget, right? So like we think experimentation budget is negligible, but we often ignore this experiment, even from a governance point of view, right? This is something that we have to consider.
Yeah. So another is like continuing old way of working, where I'll say like two things. One is like when you are working on a cloud, like you need to upgrade your skills as well, right? In cloud, like even if I just take an example of a compute, like multiple compute options are available. But if you don't have a knowledge, then you'll not be able to make a best match with your use case, like which compute to use, right? Another point which like Shakir has already given example, like upgrading the infrastructure, right? If you are just keep using your old infrastructure, not upgrading, then support cost will come and it will go high. Next one is like lack of cost conscious culture, where it's like within the team, as a team, you're like not taking the accountability of the cost. Like, or maybe like in some of the team we have observed, like just 1 or 2 senior team members just have the access to the billing reports. Like, so no one else is like, they're just, as a developer, just focusing on delivering the business stories, right? They're not considering the cost as another factor which should be considered. Another is like fear of commitment, right? So if you don't have a full clarity with respect to your business, right, you'll not be able to say like what all infrastructure I'll still keep on using over a period of a time, like 1 year, 3 year down the line, which actually comes up with a lot of cost saving if you can do the commitment and purchase the infrastructure upfront. Yeah. So with all these common mistakes, so next question comes as like, if as a team you decide like you want to work on cost optimization or manage the cost, right? So first question comes to everybody's mind, like where to start or how to start, right? So what we recommend is follow the money, like look at your billing reports, like all the 3 cloud providers like AWS, GCP, Azure, they provide the billing reports, right? They provide it with a well set of filters as well, where you can go look at the billing reports, like identify where your money is going, identify like, for example, the top 3 cost driver, and then you understand like where you have to spend the time to optimize the cost further, right? And even in some of the cases, like while doing the experiment, you provision a lot of resources and then you forget to destroy them. So those will be like quick wins for you and will be visible in the billing reports, where you can go and easily destroy and save some cost. Yeah.
Okay, let's come to the cost optimization techniques. So these are the optimization techniques that we are going to talk about in the future slides. So before diving into the optimization techniques, right? Let me set some context. So this is based on my experience, Ankit's experience, and few of our colleagues' experience. Sunit, who is sitting there, his experience in some other projects. This is a collection of all the experience that we have. My experience is with an Indian banking client whose annual budget was 200 crores per year. And Ankit's experience is from e-commerce and logistic clients. It's a European client. Yeah. So, like for folks who are using cloud, like which one was the first item that blew your mind? Which was the first line item that blew your mind? Compute cost, right? So we will have to optimize on the compute cost. So because it is a first line item, and if you apply for just discounts, plain discounts on the compute cost, you will get 30 to 70% savings, cost savings. You don't have to do anything, just purchase the savings plan and reserved instances, and you will like and you can save half of your budget in the compute cost alone. And like this is a three-step process that we recommend. So one is analyze the current usage patterns of your CPUs of your compute. Like we don't recommend to like commit for more than 50% of your baseline. So start conservatively. Have the monitoring have the monitoring implemented. Based on your monitoring, like you can start incrementing your commitment, right, for a period of 1 year or 3 years. So here a good example will be the shared services. So when you start, you will of course have CI/CD, you will have SonarQube, you will have like Artifactory. All the shared services can definitely be in savings plan, right? Because it's not going to shrink. It is only going to expand. The good example is observability, right? So if you have a self-hosted observability cluster, it will never decrease. It is going to increase only. You can straight away go with the savings plan for these services. And reserved instances is we recommend for managed services. It is for a specific instance, specific family of services, and even for a specific region, you can go for reserved instances. Yeah, so till this point, we understood services, we saw the common pitfalls, and in the optimization strategies, you don't have to do anything, right? You purchase the discounts, you save half of the compute cost, right? On top of this, there is something called map programs, right? So this, almost all the cloud providers provide map programs. So when you migrate from your data center to cloud, the cloud providers itself provide services to migrate and also support services to do so, right? When you do this migration, they will offer you huge discounts for the clients as well as the vendors who are doing it. You just have to follow these guiding principles, right? So the tagging strategy that you have to follow. The savings that I got from my project was huge, like 30 crores. 30 crores is what I got by just following the map program properly. On top of that, you will get private pricing. You can get into private pricing agreements also. So if you have huge volumes of network that you that the client is using, like network transfer or storage cost, like and even compute cost, right? You can go for private. You can negotiate and go for private pricing agreement also. Over a period of you can commit for a period of 5 years, and you can get reasonable discounts. This is on top of savings plan and reserved instances. Yeah. So next strategy is right sizing. This is a crucial technique, right? This is a crucial technique for cloud, because why do we go to cloud? So that we can pay only for what we use, right? So when we do a lift and shift, so we lift shift the static workloads as is to the cloud, and we forget to right size, right? So if you do effective right sizing, in our experience, you can at least save 30 to 70%. Right, so a good example is lower environment. We tend to provision the same instance type as that of production in the lower environments. So if we can right size the instance type in addition to the CPU and memory, right? So we saved around 2 crores here. And so when we talk about right sizing, we think only about CPU and memory, right? So we don't talk about disk storage as well. So we tend to over provision the disk for higher IOPS, higher throughput. So we had one L cluster for which we had provisioned higher throughput and higher IOPS based on the metrics that we collected. So we right sized the disk and we got 1 crore savings per year. And another example is databases and caches. So instead of going for general purpose workloads, you can go for memory or instances, memory intensive instances, which is cheaper than your general instances, and that can also give you considerable savings. Another example in lower environments, burstable series, spot instances. All these are good examples of right sizing and saving around 30 to 70%. Yep. Dynamic scaling, right? So in on-prem, we don't, like I said multiple times, we have static provisioning. So we will have to leverage the auto scaling, horizontal scaling architecture, right? So so that we can pay for what we use. So there are two type of scaling. One is the metrics-based scaling, and then other is schedule-based scaling. So metrics-based scaling we all know, right? So HPA in your Kubernetes cluster, Carpenter, autoscaler for your Kubernetes nodes. So that will give a reasonable savings, right? And the schedule-based scaling is your lower environments. For example, your performance environment, you don't have to have your performance environment 24/7. So you can actually shut down the cluster or bring to near zero if it is when it is not being used. And ARM processes. So ARM processes by design consumes less electricity than your AMD process and Intel processes, right? So that's why all the cloud providers offer you discounts. In AWS, you get flat 20% discounts, right? So for managed services and also for self-hosted services. So the first item that you can tackle for ARM processes, which is Graviton in your case, is managed services. So your RDS, your Kafka, EKS clusters can very well operate in Graviton, right? So in my project, I got around this 3 crores savings per year. And one little catch is that not all software operates in ARM processes, right? So you'll have to test it before you move, correct? So one such example that I have is the L cluster. So Elasticsearch, your FileBeat, Logstash, and Kibana can very well operate in ARM processes. So I had a 70-node cluster, and I was able to migrate it to Graviton and get some 2 crore savings. So it was a 70-node cluster. Same in other cloud providers as well, GCP and Azure. So you will get the same amount of savings there. And the another technique is the networking functions that you have in the cloud, right? So this we often forget during budgeting because we didn't have the tendency to do that in on-prem. Like when you go to cloud, and if you have a hub and spoke architecture, when you have data being transferred from one account to another account, you tend to provision an ad gateway. So that because that's what we had done in on-prem, right? So you have to do some port opening and all that, right? You have to follow the zero trust architecture. So you might have natted one subnet to another subnet. Similar, we will have that similar mindset when we go to cloud. So we would have natted all the traffic when it flows from one account to another account. And if it is in huge volume, the NAT gateway processing cost itself will be the first line item in your budget, in your bill, right? So NAT gateway cost. So in my case, I had application account and an observability account. So I was natting all the traffic from my application to observability, which was 50 TB traffic flowing per day from application to observability. So when we removed the NAT gateway to route tables, 3 crores was the saving that we got. And another is identify the network function which is suitable for your needs. So in hub and spoke, we often go for transit gateway, right? So so that all traffic goes via the transit gateway and goes to the corresponding VPC, right? But it is not suitable for high volume traffic. Like I said, when I have 50 TB traffic flowing from application to my observability account, so every traffic has to go to the transit gateway. And the cost is, instead we can go for VPC peering connection directly. So if you take transit gateway cost, it is $0.02 per GB. Whereas your VPC peering connection processing charges is only 0.01, which is half. Right? So if I take 50 to 60 TB, my transit gateway processing charges between my application and observability is $1,000 per day. Right? So if I move to VPC peering connection, I halve it. I save half of the cost, which is $450 per day. And also the managed services cost that I told, right? So that also will be huge. So it will be around 2 crores or 3 crores. In my case, I had 60 EKS clusters which were not migrated from 1.29 to the latest version, and hence I have to pay a huge amount. So when we migrated it, we saved around 2 to 3 crores.
Yeah. So next is like managed services. Like so in cloud, like most of the services are either managed or either they are serverless, right? So I think identifying the use case and then matching it to the right service is one of the important thing. Otherwise, like it will incur a lot of cost. Here would like to take one example, like where I was working with one of the team where we were working on a GCP, like we were using Cloud Run, right? And there, what we observed is like our load was just like 20 requests per second, the HTTP workload, right? And what we observed is like during the peak time, there were like 35 instances running for a Cloud Run, right? Which is like not matching at all, right? 20 requests per second, why 35 instances running, right? So what we did is like we went ahead, tried to understand like how the scaling works on this particular infrastructure, right? And then we tested our application, right, with the performance load. And then what we observed, like even if we run it with a 5x load, right, we are still able to handle it with 20-25 instance. Obviously, there will be some failures, but if you have a better resilience in a place, then it should be fine, right? And then what further we observed and did is like you'll be surprised to know it was not an infrastructure change, but it was something else which helped us reducing this cost. What we observed is like all the requests were taking like more than 500 milliseconds to process. And what we did is we upgraded the Java programming language version and we applied the virtual threads, like we enabled those threads in our application. And then automatically what happened is like our latency reduced, which went down like below 500, like for some of the requests like 200 to 300 millisecond as well. And the automatically even just one container was able to handle more concurrent requests. And that's how the overall maximum container which was going above 30, now it's like within just 5 to 8 containers we are able to handle the peak load as well. And with this, like this much of a saving we have done with just one Cloud Run application optimization. And even if we go ahead and apply it across like for the whole project, then you can just multiply this number, you'll see like how much cost it will. The next is like storage. So storage is like another area where cost accumulate quietly, right? Because this is like one of the resource which we generally go ahead and provision and then we forget about it, right? We just keep on using them. So where like these are like two types. What we see is like structured, which is like databases, where we just simply go and provision them, and then later on, like we just keep on accumulating like lot of data into them, right? And then we later on when we see or get notified, okay, it is taking a lot of cost, then only we do and take some actions, right? But what we recommend is like as soon as you're using any of the database or the table, like you have a better clarity on the pricing model, and then understand like how you want to archive your data, right? So before starting like creating any table or like any database, right, you should ask this question to yourself, like what should be the retention period of that data, like so that you apply the archival strategy automatically at the same time. Similar thing applies to this unstructured object storage as well. Like there also we go ahead and create storage buckets like in GCP or S3 in AWS as well, right? So there also like they provide with this feature like lifecycle policy, right? So whatever data you are going to store or whenever you're creating that bucket, right? Again, the same question comes in like, what's the retention of that data, right? And then automatically apply that policy. So this is what we like recommend in this too. Now let's look at like one of the example, which again, we did with one of the team, again on GCP. So here like team was using Datastore. Again, it's a serverless database option. And what happens is like this works on a read-write operation basis, the pricing model on this one. And what team was doing, like they provision the database and they will just keep on using. Like over a period of a year or 2 year, the data size will grow, right? And while taking a backup, and they were like taking a backup on a daily basis. So one thing, like what we did is like, do you really need a backup on a lower environment, like on dev environment? Maybe you don't need a backup, right? And even on your non-live or non-prod environment, again, you can reduce the frequency. And further, like since it works on read-write operation basis, like with respect to cost, so what we did is like we started applying time to live feature so that your data gets archived automatically. The size of the database should not grow after a particular limit. And even in this one, it's not like we just technically went ahead and applied that time to live feature, but we actually went ahead and talked to business. Like even for similar set of our data, there could be a different business scenarios, right? One business scenario, we just need data for a 1 month, right? For other business scenario, it could be needed for 6 months. So you can further drill down it further to understand like which data you want to keep for a month or 6 months or a year. So this much of a cost saving like we did while working on this cost optimization for GCP data store. And this is also like with just one team. Like if you apply similar thing, you're using this with 10 different teams within a project, then how much cost can be saved? Yeah. So next is like operational resources. So like we all know when we are working in any particular project, right? We use a lot of operational resources like logging, monitoring, alerting, right? So one of the question which we recommend to ask is like, we definitely need all these things on a live environment, but do we really need the same on the dev environment, right? We can still live with limited set of operational resources on the dev environment as well, or maybe on the non-live as well. Further on this one, like one example we have, where we reduce the monitoring or alerting, like for example on the dev environment. And another thing is like sometimes you're using some external tools, like even while working in a cloud, you're using Kafka, which is outside your cloud. And you have some applications like data producer or data consumer from a Kafka into your application. And then sometimes you may want to scale those things or scale those compute instances or the application on the basis of like Kafka specific metrics. Like as a consumer, I may want to like expand or scale further on my instances based on Kafka lag metric, right? Then it's like we need that metric into the GCP or in any other cloud to further expand those things. Like, so what happens is like we most of the time went ahead and apply capturing all the metrics, right? Ingesting all the metrics in any of the cloud is again, cost will go up. So you need to filter out those things, just capture those specific metric. And this is like what we applied with one of the team, and this much we have saved like just with one team on GCP. Next is like cost conscious culture. So apart from the other optimization techniques which we can apply among different resources like compute, storage, network and all, right? This is what we recommend is like to bring that culture within your team, talk about more on the cost. It should not be just the responsibility of a finance team or just 1 or 2 person, like senior person just looking at their billing reports. It should be a habit of a team like doing this activity on a regular basis, like at least once in a month. The next is like, these are some big numbers. These are like from the overall projects. One thing to highlight is like we have applied this strategy among all 3 different clouds like AWS, GCP and Azure. And another thing to mention is like this is applied against like different domains. Like first 2 are the example from a financial banking domain. Third one is like we applied in e-commerce logistic platform. And the 4th one is in the healthcare department. Yeah.
So we have applied the optimization strategies. Now, what do we do? So it is not a one-time process, right? So cost optimization is not a one-time process. It is a continuous process, right? So this is the FinOps framework that we see, which is inform, optimize, operate. Like how many of you know the FinOps framework, right? So this is the same, right? So these are the 3 pillars of the FinOps framework, and the first The first and foremost is the democratization of cost data. So the managed, the extended support cost that I was talking about was only visible for the executives and engineering managers, not to the people on the ground who really wanted to upgrade the EKS cluster. So you see the disconnect, right? So as a developer, I want to be in the latest and greatest, but the engineering managers only have access to the cost dashboards, and that is creating a dent in the budget. And like there is huge mismatch of expectations going on, right? So first start by democratizing the data. You advise your clients to democratize the cost dashboards, like kudos dashboard in AWS. Give access to everyone, all the developers, right? And also the utilization of resources also should be visible to everyone. So next is the delivery infrastructure platform. So we like start empowering your teams to automate everything. Don't manually provision. Start with IAC and then go on to the next maturity, which is your delivery infrastructure platform with sensible defaults baked in. Right, so make it easy for your developers to create the infrastructure, like with for example VPC flow logs disabled, right? So all these things you can build, and final one is the governance, right? So in the experience that I shared, so I was brought up. I joined a team with a couple of principal engineers to optimize the cost, right? So from outside it might look different. So we are advocating for develop lift shift and all that. Like I joined as a consultant to a client to optimize cost, right? But this is a continuous. But you think about it. So if you have a huge volume, there is better to have a governance layer also with 2 or 3 engineers working continuously, monitoring and working on this. Right, and the one thing that I want to emphasize on this FinOps framework is don't empower your teams. Don't empower your teams to just do cost reduction. Right, optimize for value. Right, so that's one thing that is a takeaway for me in this FinOps framework.
Yeah. So apart from this optimization strategies, like these are some of the metrics also, the KPI which we recommend to look at is like how much you're spending, like try to drill down and understand it like from a application specific purpose as well, and look at like how much you're spending per environment as well. And like we definitely end up using like CPU memory, then you need to understand like how much it is utilized or how much it is still sitting idle, right? How much you're using ARM processor from the compute perspective, right? And whether all your different resources are covered into observability coverage or not. So these are like some metrics which we also recommend to look at like while working on this optimization strategy.